भोरे सर एकदा ते वर्ल्ड पीस प्रेयर आणि पसायदान टेस्ट करून बघा बरं का.
Hello, Malik sir.
Yes, sir.
Can you please tell our speaker to stop sharing the screen?
Yeah.
Thank you, sir.
Vikram sir, can you hear me?
Hello.
Hi, yes, sir.
Can you hear me, sir?
Yes, sir.
Okay.
Dr. Mane sir, can we start?
Yes, sir. We can start.
All right, sir. All right then.
माने सर
Yes, sir.
Yes, sir.
तर शेअरिंग स्टॉप करायला सांगा
Shall I?
स्पीकरला.
Okay. Shall I share this PPT?
Just a minute, sir. Vikram sir, just a minute.
Okay.
हॅलो विक्रम सर.
Yes, sir.
तुमचं तरी ते पीपीटी शेअर करू नका.
नको ना? Okay.
Just 2 minutes, sir. Just stop the
Okay.
sharing.
Okay. No issue. No issue.
Yeah.
सांग की पटा सर.
Hello, am I audible?
Yes, sir.
Yes, sir, you are audible.
I request Mane sir to please stop sharing his slide so that we can share from our screen.
Vikram sir, just stop sharing. So we have
Okay.
some technical issues. Just stop sharing.
Okay.
Then
Okay. Okay.
within a minute we will start it. Yeah.
Okay, sir. No issue.
Dr. Mane sir, shall we start?
Just a minute, sir. Bhore sir, is it fine? Bhore sir, can we start? Is it fine now?
येस सर स्टार्ट सर.
Sakre sir, you can start.
Am I audible?
Yes, sir.
Okay. So, very good morning to all the participants, all the people who are available for today's webinar on the recent trend in gauging system in Industry 4.0. I would like to welcome today's speaker of our webinar, Mr. Vikram Mane sir. Welcome you sir, on behalf
Thank you.
of MIT College of Railway Engineering and Research. I would like to welcome you, sir.
Thank you, sir. Thank
So, as a tradition of MIT group of institutions, we start every program by World Peace Prayer. So I request our technical team to please start the World Peace Prayer.
नमो जियाद्या वेद प्रतिपाद्या जय जय स्वसंवेद्या आत्मरूपा देवा तूचि गणेषु सकलार्थमतिप्रकाशु म्हणे निवृत्तिदासु अवधारि गोजी गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरः गुरुः साक्षात् परब्रह्मा तस्मै श्री गुरवे नमः। पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते। ॐ शान्ति शान्ति शान्तिः।
Thank you, sir. Thank you so much.
you, sir.
Industry 4.0 has brought forth a revolution where smart technologies, automation, and interconnected systems are reshaping the manufacturing landscape. Gauging systems as critical components of precision and quality control have also evolved significantly to align with these advancements. So the topic we are about to discuss today holds immense relevance in both academia and industry, bridging the gap between the theoretical knowledge and its practical applications. We are honored to have you today here, sir. Thank you. Thank you very much. Now, before moving forward, I would like to ask Dr. Sanjay Mane, sir, to please give his welcome address.
Sure, sir. Am I audible, Sakre sir?
Yes, sir.
Okay. Good morning, all. Warm welcome, respected speaker, Mr. Vikram Mane, all faculty members, and dear participants. Industry 4.0 is more than a buzzword. It is a paradigm shift that integrates advanced technologies like IoT, AI, robotics, and data analytics to revolutionize industrial processes. Particularly aligning with the today's topic that gauging systems being at the heart of precision and quality are evolving to meet these dynamic demands. It is with great pleasure that I welcome you all to this webinar topic on recent trends in gauging systems in Industrial 4.0. This session promises to be an insightful exploration of the transformative advancements shaping the future of industrial operations. I encourage all participants to actively engage, ask questions, and make the most of this opportunity to learn from experts and peers alike. Once again, I extend a warm welcome to everyone present over here and wish this webinar a great success. Thank you.
Thank you, sir. Thank you for your welcome address. Our principal, sir, Dr. Madhukar Lengre, is right now busy with his some of the administrative work. So now, moving forward, today we are honored with us today. We are honored with Mr. Vikram Mane, sir, who bring invaluable insights and expertise in this domain. Their perspective will not only enrich our understanding, but also inspire us to think critically and creatively about the future of industrial technologies. I feel immense pleasure to introduce our today's speaker, Mr. Vikram Mane, sir. He has completed his ME in CAD/CAM and robotics as the expertise. He has a total 24 years of best undertaking experience in Mumbai, 2 years of experience in UNIMET Gauges Pune, and also 4 years he has worked as the HOD of Mechanical Engineering, Pillai College of Engineering, Panvel. We are very much honored to have you with us today, sir. Thank you.
Thank you, sir.
Before taking more time, or without taking more time, I would like to ask today's speaker of our webinar, Recent Trends in Gauging Systems in Industry 4.0, Mr. Vikram Mane, sir, to please start his session. Thank you, sir.
Okay. Thank you, sir. Can you hear me, sir?
Yes, sir. Yes.
There is some issue in camera. That is why my video is you cannot see
No
my
issue, sir.
video,
No
but
issue, sir.
I can share my PPTs and videos on through my screen. Okay.
All right, sir.
So first of all, I would like to thanks to MIT College, and I have hear your that wonderful prayer for the world from your World Peace University or WPU University. We are very much honored from our bottom of heart to your founder, Mr. Karat, sir. We all are maybe his students. We are proud of him, and we are definitely proud of your MIT management as well as your college team, sir. Sir, with this, I will start this today's presentation.
Screen is not visible.
Now it is visible, sir.
Yes, sir.
Okay, shall I start?
Yes, sir. Sure.
Actually, presently, just I'm working with this UNIMET Gauges and OPTAC Measuring Technology Private Limited. So that I'm dealing with this gauging technology from last 2 years, and I would like to share the what is the recent trend in this gauging systems is today's need of this market as well as the today's need for the industrial revolution of 4.0. Now just we'll go some basic things of this metrology.
Hello, sir. Sorry to interrupt you.
Yeah.
Your screen is not moving. I think it is stopped. So you can just.
Uh, yes, sir. Now it is. Can you see this slide metrology?
No, sir. No. You can do one thing. You can
Huh?
unshare it and again share it.
Okay. Okay, sir.
No, sir, we are not able to see the slide. We can see the screen, but we are not able to see the slide.
Excellent.
I request all the participants to please keep patience. We are trying to find out the technical glitch.
Hello.
Yes, sir. Sir, you can do one thing. You can share your PPT via WhatsApp to Dr. Mane, sir, so that he can share it from his own login.
Now just
Earlier it was that's fine. That is, you have already shown the PPT. I think
yeah.
some
Now
issue.
now I have said it again.
I think you have to share. I think you have not shared. You have to share the PPT. Just open. Yeah, yeah. Now it is visible. It is visible, sir.
Okay, sir.
Thank you,
Uh,
sir.
Yeah, just make it zoom. That is, just enlarge it, maximize this
okay,
page.
okay. Okay, sir. Can you see this? Hello.
Yes, sir. Yes, sir.
Okay, I will start with this.
Sure.
Sir, this is our company, that is OPTAC Measuring Technology Private Limited and Universal Metrology. We are dealing with the gauging systems and the advanced gauging systems that we are catering the recent need of the market. Now, just we will go some basic. What is the metrology? That each and every engineering students aware of that metrology. Metrology is the nothing but it is the science of the measurement. I will not go too much in the details of the theory because this is the basic. These are all these basic things. That being a mechanical engineer, we should know the metrology, and we have already we are studying the metrology. I think MQC subject, right? Metrology and quality control. Maybe,
Yes, sir.
sir, the students are from all the means faculty from this first year to final year, or only second year, third year, final year students are means audible for this PPT presentation. Students from which class? Because so that I will explain in that way, whether they are in the first year or second year or third year or final years. Yes, sir.
So most of the final year students, sir,
Okay,
and
okay,
as
no
well as
issue.
the diploma as well as degree faculty members are also there.
Okay, no issue, sir. Then everybody knows for the metrology science. Okay.
Yes.
Now we are dealing with the dimensional metrology because there are different types of metrology fields. That is the maybe in the various fields. That is the weather metrology. You can say temperature. You can say pressure gauges. You can say temperature gauges. Another sensor gauges are different. And we are dealing. Our company is especially dealing in the dimensional metrology and especially in the linear measurements. Now, if we deal with the metrology science, then we comes to the actual definition of the accuracy and the precision. Now, we should know these are again basic definitions. That is, accuracy is the agreement of the result of a measurement with the true value of the measured quantity. And precision is the its repeatability of a measuring process. Now, What is the accuracy? What is the precision? Now, we know that we come across all these precision manufacturing components. All the companies written that writes on their boards or maybe in the names of their companies. They always write that precision component manufacturing. So now, what is the precision and what is the accuracy? There is difference, slight difference means we should know the basic things. Accuracy is the nothing but it is the agreement of the result of measurement with the true value of measured quantity. And precision is nothing but it is a repeatedly or repeatability of the measuring process, means repeatability of this gauges or repeatability of this measuring scales or maybe verniers, maybe micrometers. That is called precision. And accuracy, it is some value along with some agreements which are accepted worldwide. Again, this graphical representation between the accuracy and precision. Now you see in the first graph, that is the dimensions and frequency graph. This is the true value, indicates one central line, and average values are on that true value line. And in this, in second graph, the true values and the values or the readings are by the two sides of this central line. Now that you have to define which instrument or which instruments you are getting the precision values, and repeatability is good for the that instrument, or maybe gauging instrument, maybe your scale, maybe your vernier calipers. That again you have to take the call for your instrument or measuring process. These are the basic tools. We all are familiar with this, that is vernier caliper and micrometers for the linear measurements. Again, this is the diagrams just I have included here, that we all are familiar with this. Now, from these conventional gauges, that is vernier calipers and micrometers, that for the mass production or to the batch production, to avoid the cycle time of the checking cycle time or cycle type inspection, you can say, that to minimize the inspection time, some gauges introduced in the quality control department or inspection department, which are uh, familiar, or which list count of that gauges are that correlated with the first principle gauges, that is the vernier caliper and micrometer gauges and the height gauges. Through the correlation, they are manufactured or they are designed some another types of gauges, which we have to come across in the conventional gauges methods, that is the go gauges, no go gauges, plain gauges, thread plug gauges. These are the different types of gauges. Just I have shown here the pictures. That is the plain plug gauges. Here there are two pictures. One is plain plug gauges, that is plain plug gauges, and the another is snap and ring gauges. Here, through these gauges, you can handle the inspection of the mass production as well as the job production up to maybe some 10 to 50 microns list, the tolerances, you can say 10 to 50 micron tolerances you can check through this plain plug gauges and snap gauges. Maybe it is above 20 microns, because after broad tolerances, where the broad tolerances are there, 20 micron to 50 microns and more than 50 microns, you can use such types of plain plug gauges and snap gauges. And you cannot observe any readings here. Just one end is for go side and another is for no go gauge. These are the conventional gauges. This is the tolerance for the incorporated for the go and no-go gauges. It is the unilateral as well as the bilateral tolerances are there. Unilateral, that you are already familiar with that. It is only one side, and bilateral means it is both sides tolerances applied on this gauges. Now come to the some advanced techniques from last maybe 25 years. They are introduced that is air gauges. Now air gauges, how it works? That air gauges, it is a non-contact type compared to measuring methods, and it has been introduced in this market that more than 80 years. But in India, we are using only from last 25 to 30 years only. Now, this concept of air gauging is based on the law of physics that states flow and pressures are directly proportional to clearance and react inversely to each other. Means again that measurement values comes on the dial gauge, maybe in the form of analog or maybe from in the digital way through this physics only. That is the flow of that fluid flow or air flow is directly proportional to the pressure and its clearance. This is just one of the diagram of this concept principle, you can say working principle of the air gauge. Air passes through this port, and that black, it is the actual component. Now here this is the two jet air ring gauge. Through this, from the both the sides across the diameter, you will get two jets, and there is clearance, that is the white. It is indicated in the white color, and black color indicates actual OD, that is the outer diameter of this component. Through this principle, you can observe the final dimension of the component, that is the OD. Now this is the same principle again to measure the ID, that is the inner diameter of the component. That yellow color is the component, and the black color again it is the air plug gauge. Here one port, single ports comes, and two jets. Again there is clearance is provided. That clearance is near about to 20 to 30 microns as per the different design parameters from the different companies. Now this is the actual picture of the gauges, air plug gauges, then air ring gauges and air snap gauges. You can measure with this air plug gauges, the ID you can measure. You can measure the OD through these air ring gauges, and again you can measure the outer diameter of the shaft through this air snap gauges. Now these are the different types of gauges that from the conventional gauging systems, customized solutions, and latest development. Here we have already seen these conventional gauges, that is the air ring gauges, air plug gauges, air snap gauges. Now come to the customized solution. Now here, for the customized solution, it is again need of this Industry 4.0. The gauging fixtures, we have to design multi-gauging systems that you can measure multiple parameters, one single system. Again, there is semi-auto gauging, means loading and unloading by manual or maybe through gantry or maybe through robot. Again, auto gauging, loading and unloading through robots and gantry. And there are some electronics readout systems. Then auto correction to machines also. And the development in the recent trend is again GRT, that is the gear roll testers. Maybe manual and auto gear roll testers are there. to check the profile of the gear teeth. Now, just this is the uh, slide for this Industry 4.0 revolution. Now, what is the revolution and why it is the necessary for the present market? Because see, nowadays it is very difficult to get the skilled labor across the world. Now, the each and every problem creates some revolution in the global society, or maybe as per the need of the manufacturing market. Now, due to this, the main problem of the manpower, that skilled manpower, and the to cut the cost of the manpower, this revolutions comes into the picture across the whole world. And we, being our the dream of our Prime Minister, Sri Mr. Modi sir, this Industry 4.0 is now going to compulsory for each and every manufacturer, unless and until they don't any manufacturer have don't have any facility of this Industry 4.0, they are not considered for the global platform. For that is why India become going to an manufacturer hub, auto manufacturer hub for the whole world. You can also hear the different news also from the uh, business news, or from the any inaugurations from our industrial minister also, that now what is the Industry 4.0. Now you just observe this slide, you will come to know that all the latest technology used for to grow the manufacturing, to the increase the productivity of the manufacturing, to increase the quality of the manufacturers or production, to analyze the data, to observe or to control any manufacturing facility from one single place. If you are sitting at your village, or if you are sitting at in the corporate office of US, or if you are sitting anywhere of the world, you can observe each and every data, each and every manufacturing data by sitting in your office, and it is a live data, not only that is historical data. That is why the Industry 4.0 comes into the picture. Now here, for the mechanical engineers, or it is the combination of the mechatronics, you can say, not only mechanical, it is the trend of the Industry 4.0 needs, that is the mechanical engineers, electronics, plus computer, IT. This again, mechatronics branches comes into the picture. It is the combination of mechanical, electronics, and computer. If you observe from this side, you should know this autonomous robotics, you should know simulation tools, you should know system integrations, that is how to integrate the different types of machines, gauging machines, your administrative machines. That is again integrations come to the picture. Then IoT comes into the picture. Then again cyber security, means your data should be safe. For that, cyber security comes into the picture. Then you have to store your data securely. That is cloud computing again comes into the picture. Then additive manufacturing. Then manufacturing, it's again, it is the part of your integration. Different advanced technology comes in the manufacturing, because to integrate or to correlate with your Industry 4.0, you have to upgrade your machines, all the machines. And this big data analysis, that you can say all the data you have to say there, store there. And again, this each and everything comes into the picture that we are to going to observe all these things through this uh, augmented reality things. Okay, now just this is the brief of Industry 4.0, means it's combines all the branches in on the one platform. Now again comes to this gauging. Now here that we have already seen the different types of gauges.
Just a minute, sir.
Yeah.
If you shift, if you press shift and F5, it will get full screen, sir.
1 second, sir. Okay.
Yeah, it's fine, sir. Now.
Okay. Thank you, sir.
Okay, thank you.
Now comes to this gauging field again. We have up till now we have uh, gone through these conventional gauges, that is the go gauge, no go gauge, air plug gauge, along with analog or dial type gauges. Now comes to this electronics type of gauging units. Now these units along with one gauging fixture is there. This is one simple example of Industry 4.0. Now these units here there are you will get the SPC. This unit is based on the SPC software. Again, you will get the real-time data of this gauging data on this unit. There are three bands are there: one green, yellow, and red. If your production is going on within the band or within that tolerance band, there are different. Suppose plus or minus 10 micron is your tolerance. If you want to set your band, green band, that is within 5 plus or minus 5 micron band. Now, if you check in components, these 4-5 ports are for the air or maybe for contact type inputs are there. This is the 5-channel unit, 5 input unit. Here, if that production is within tolerance of 5 microns plus or minus, it will be reflect this graph. That is this chart is known as the CP-CPK chart, that will control processing unit. That is the CP-CPK values you will get here. Now this is the red band is showing your production is within your range. Yellow band is for your component maybe rework, you can carry out the rework, and the red band is for tolerances, your manufacturing component tolerance, or its actual measuring data is out of the tolerance, that you have to reject the component. Now this is the second type of unit. This is as per compared to cost, it is economical cost solution for the manufacturers. This is the microprocessor based unit. Again, this show the gauging value uh, uh, through this digital readout unit. You will get the if the values are within tolerance limit, you will get the green reading, and if the measuring values are more than the tolerance values, then you will get the red. You will get the red digital in the red digits. Here there is facility for the green and red digit readings. Now again, this is the gear measurement through this digital unit. Here you can measure the OBD, that is the overall diameter of the gear, and again it will show on the electronics readings. Now after these are simple solutions, digital solutions, you come to the advanced types of gauging systems, that is multi gauging and auto gauging systems. Now what is the multi gauging? You can check 2, 3, 4, 5 up to 40 or 50 up to 100 parameters or dimensions at one time. Means more than 2 parameters in the multi gauging you can cover within single stroke, and within 50 to 55 seconds you can check all these 100 parameters or 50 parameters. You can save the time for the inspection is around 1/10 Manual means 10 times manual time you can save through these machines, and you can save the 10 persons from through the one machines, one gauging machines. This is the real benefit of the machines. To avoid the manual interferences, that advanced gauging systems comes into the picture. Now all the benefits and advantages written here, that is you can save the efforts, no need of specialized skill or operators. Again, skill problem is there. Then elimination of human error, machine always tells truth, and you cannot miss any parameters, and you can see the all the data, that all these machines save the data uh, at the server or in the computer or CPU. All the gauging data you will get per shift or as per your number of components checked per shift or per day. Now this is the layout of some gauging machines. That is, this machine is made for the to measure the oil pump shaft dimensions. Now here you, if you observe, you can measure near about 18 to 20 parameters in single stroke. This is the actual machine. I will show the videos of this also after completion of this presentation. Now this is the oil pump shafts are moving on the this base conveyor, then goes to gauging stations, and again all the parameters are get recorded, stored in the computer, and show the readings of whether it is okay or not okay. This is the actual machine again for the oil pump shaft. This is the second component, that differential case, that differential cage you can say. Here you can measure here ID of both level and distances of the different levels with respect to its bottom. This is the actual machine. Again, this is the depth case multi-gauging system. This is the horizontal type fixture. Earlier it was vertical type. Now you will get the computer screen here, gauging fixture. Now come to this another multi-gauging system, that is the 23 parameters you are going to check for this one shaft here. Within 30 to 35 seconds, you can check all these 23 parameters. Means you can avoid the manpowers. 1/10 of manpower is only required for this gauging system. This is the actual machine. Again, this is the connecting rod along with digital connecting rod fixture along with digital units. Means each and every data you can store here, and you will get per shift wise data, how many components you are checked, how many components you got the okay components or rejected components, what is the productivity, what is the loss per shift, what is the profit per shift through this quality inspection or digital revolution you can say. Again, this is the multi-gauging for the shaft. Again, this is the multi-gauging for the camshaft. Just I will move this PPT, then I will show actual videos, then you come to know how it works. This is shaft. You can measure the all the OD parameters of the shaft, camshaft, and camshaft profile also you can get here. This is the ring gear. This is the gear, and again this is the digital readout unit along with for the measurement of the gear. Again, you can check ID, then teeth OBD you can check, and face, that is the height of that gauge, width of the gauge also you can check in single stroke. This accuracy is you can check within 2 micron here. The least count of these gauges are 1 micron, and repeatability is again it is lies in the 2 to 3 micron. Now these are the gear roller testers to check the gear parameters. That is the DFC, TTC, that is double flank composite error, tooth to tooth error, composite error. Now this is the auto GRT system. Here you can check the gear parameters. Here you can check the 2 gear parameters in the single machine. Here you can check the 3 gears parameters through single machine. This is the crankshaft assembly. Again, you can check gear parameters along with shaft dimensions. Now, this is the multi-level GRT, that is gear roll tester. You can check the 5 gears at a time for the single transmission shaft. These are some electronics units. Again, just I will show this. You can check different types of IDs or ODs through single unit, from single digit to single input to 8 input, or from single channel to 8 channel, from single display to 8 display parameters. You can observe through single unit. Now this is the SPC software based unit. You can observe this unit, or you can read this data through your mobile phone also, through the Wi-Fi connectivity. Again, here from single channel to 8 channel, 8 input, you can observe all these parameters in single unit. Now this is the remote monitoring system, that is from different operations for different units data you can observe or monitor from your cabin also. This is the big screen. You can set into your cabin and observe all the floor machine shop floor data from all the units on a single screen. This is the line control. Different line control line data you can observe from the single screen again. Again, this is again industry 4.0 application, that is auto correction to machines. Now you have to set, you have to reset your tools, CNC tools, through this auto correction unit. But to avoid the manual interference, the auto correction to machines, that is CNC machines, you can reset your tools automatically without interference of the manual interference through this gauging unit plus auto correction unit. It corrects the tools, or it reset the tools automatically through this gauging unit. This is the actual picture, and these are the specification of this unit, that is auto offset controller. Okay, we will go through some videos.
Okay, sir.
Okay, just I will show some videos, sir. Now, just I will start this video of this Industry 4.0 advanced technology machines. Sir, is it visible, sir? Hello?
So the screen is visible, but the video is not playing right now.
Not playing? Okay. Hello? Hello?
Yes, sir.
Can you can you observe this screen?
Yes, sir. Yes. You can increase the volume of the system or the PC which you're using.
Okay, okay. Video is clear now?
Yes, sir.
Okay. Now this is the to check the gears, different parameters of gears. We are given this system. This is completely automation gauging system. The loading and unloading through this gantry systems. This total machine is designed in-house along with all softwares, electronics, hardwares, and mechanical things. Now, there are two conveyors are there. One is green color is for the OK components. One is gauging station, another conveyor is for the OK components, and the red band is for not OK component. Sir, you are observing this? Hello?
Yes, sir.
Okay,
Yes,
okay.
yes.
Sir, how many parameters it check?
Here we are checking near about 6 parameters. That is ID and OBD and the width and its face run out and the PCD, that piece circle diameter of this component.
Okay, sir.
Now I will show the another video. Now, sir, can you observe this video?
Yes, sir.
Now this is the robot integration system. Again, fully automation system. See, we have started from the conventional gauging systems, that is from vernier calipers, micrometers. We have reached this industry 4.0. Fully automation is needed here without any manual interference. Each and everything you will get all dimensions checking through automation only. That is loading and unloading through the robots. And again, robot will keep the OK component in the OK bin and not OK component in the rejection bin. See, the another component will be loaded here. Now, after the completion of inspection, there will be laser marking. If the component is okay, through this laser marking, there will be creation of the QR code. And against that QR code, that PC will be store the data of that component. So for the when this shaft will go for the assembly purpose, again for the final inspection through the scanner, you can observe the total dimensional parameters of this shaft for whether it is suitable for the assembly or not, and all the data will be accessed through this QR code at any place in the world. Now Here you can check the different parameters of the gears. There is one shaft and other are masters. This is the transmission shaft. There are 5 gears on this shaft. Within 50 to 55 seconds, this cycle is needed for the inspection. Now that all the 5 master components are there, gear master component, we have to check all the gear parameters with correlation with these master components, whether their teeth are matching their profile with these masters or not. See how many parameters you have to go to check within a single stroke. Again, this is the vertical mounting machine, that is the vertical axis machine. Again, here you are going to check the 3 gear components. If any dent or any burr found on the teeth, you will get that variation in that profile. This video already completed, sorry. This is the differential gauge multi-gauging system.
Hello, Mani sir, am I audible?
Yeah, audible, sir.
Yes, sir. Yes.
It will be last video. Okay. Hello.
Yes,
Okay.
yes.
Uh, just sample videos I have shown. See, actually, this is the recent trend, sir, because all the students and we should aware what is the industry 4.0. Each and everything is upgraded now, and all these things are comes in the manufacturing. That automations comes into the pictures, and integration of all the data, administrative, manufacturing, all things you will get on single platform. This is the recent trend, sir, in the gauging systems. Just I
Okay.
have shown this video for that purpose only.
Okay, sir. Okay. Thank you so much for your insightful webinar. Uh, there are two questions from the participants. The first question is, what role does real-time data integration play in modern gauging system?
Yeah, sir, actually, the real-time data is playing, you can say 95%, that is the participation of the real-time data in this industry 4.0 revolutions, because each and every there is very close observation from the top management on each and every manufacturing data of the hourly wise, maybe on the shift wise and the day wise data, manufacturing data. They want to take corrective action immediately after observing the performance of this manufacturing performance, you can say hourly. If you are getting all the parameters correctly, they will observe from EVS corporate office, and you are manufacturing at your barship at MIDC. Yes, your data will be get observed through this server from the corporate office, and they will give the directly corrective actions or take necessary steps through that corporate office to your plant immediately. Now they will say that your component tolerances are increasing. Just take reset your tools or reset your system, or see what is going wrong. Means through this data only, real time data. That is why it is necessary in today's manufacturing sector, sir.
Thank you, sir.
So.
Thank you so much. And there is one more question, sir, for you.
Mhm.
Can you provide the examples of how AI and machine learning are being leveraged to enhance the performances and adaptability of the gauging systems?
Sir, presently this AI is the new tool for us also, and just I will say that we have one AI expert in our company also. Maybe if you give him platform for what is the AI used in this manufacturing, definitely he will clear your all the doubts of the AI, because this is the present tools, but still it is not practically working in the manufacturing. They are just, it is introduced there. Now the observation of the applications of AI in the manufacturing is going on. But again, AI will also play one of the important roles, that how to take the decision without interference, manual interference again, through the machines only. Now you can say we have already learned in our subject, that is the adaptive control. Adaptive control systems, you have already gone through this control systems subject. May I write, sir?
Yes, sir.
Hello.
Yes. Thank
Because
you.
adaptive controls is through these adaptive controls, that corrective measures takes by the data analysis through this AI. If you will find some deviations in the tolerances, and this data analysis automatically completed, and the AI comes to the picture to take the corrective action and give the actions, corrective actions, send the corrective actions to the that particular machines. Up till now, they are planning for that. Still, for practically, we have working on that, but it is not comes into the picture, real pictures in our company, sir. So that
Thank you.
it is in practice. Again, it needs some time.
Okay, sir. Okay. Thank you. Thank you for the answers which you have given to the questions raised by our participants. Thank you, sir.
Thank you, sir. Thank you.
Thank you so much for your insightful presentation today on the recent trends in the gauging system within the context of the Industry 4.0. Your in-depth analysis of how advancements in sensor technologies, data integration, and AI are revolutionizing industrial processes was truly enlightening. It is clear that these innovations are not only enhancing accuracy and efficiency, but also shaping the future of manufacturing. We greatly appreciate your time, expertise, and the valuable knowledge you have shared with us today. A big thank you to all our participants as well for your engagement, and we look forward to continue these discussions in future sessions also. Have a great day to all of you. Thank you. Thank you very much, sir. On
Thank
the
you. Thank you.
behalf of MIT College of Railway Engineering and Research, I would like to say a very big thank you to you, sir. Thank you.
Thank you, sir. Thank you. Welcome.
Now,
Vikram sir,
Okay. Yes, sir.
can you please stop sharing?
Yeah.
yes, sir. Yes. Now, with the permission of the dignitaries, I declare that today's webinar is over. And as a tradition of our MIT group of institutions, we conclude our sessions with Pasaidan. So I request our technical team to please play Pasaidan.
आता विश्वात्मके देवे येणे वाग्यज्ञे तोषावे तोषोनिमजद्यावे पसायदान हे जे खळांची व्यंकटी सांडो तया सत्कर्मी रतिवाढ भूता परस्परे पडो मैत्र जीवांचे दुरिताचे तिमिर जाओ विश्वस्वधर्म सूर्ये पाहो जो देवांशील तो तेलाह प्राणी जात वर्षत सकळ मंगळी ईश्वर निष्ठांची मांदियाळी अनवरत भूमंडळी भेट तू भूता चला कल्पतरूंचे आरह चेतना चिंतामणींचे गाव बोलते जे अर्णव पीयूषाचे चंद्रमे जे अलांछन मार्तंड जे तापहीन ते सर्वाही सदा सज्जन सोय रे हो तू किंबहुना सर्व सुखी पूर्ण होनी सिही लोकी भजिजो आदि पुरुषी अखंडित ग्रंथोपजीविये विशेषी लोकीये दृष्टादृष्ट विजये हो आवे येथ म्हणे श्री विश्वेश्वराव हा होईल दान पसावो येणे वरे ज्ञान देवो सुखिया
Thank you, sir.
Thank you, sir. Thank you.
Thank you, Mane sir, for joining us. Thank you very much.
Thank you, sir. Okay.
Thank you, sir. Okay. Thank you.
Thank you to all the participants.